Hello friends. Uh, so today is our day 4 for solving problem of the day from GFG. So let's look at the question. Okay. So what is saying? Given a number n, find count of all binary sequences of length 2n such that sum of first n bits is same as sum of last n bits. The answer can be very large, so you have to return answer module this 10 to the power 9 plus 7. So let's take this example and understand the problem. Okay, so let's take this example. Right. Okay. So what does the question is saying? What does the question is saying? Let's see. So we have given a number n, right? So we have given a number n. Suppose n is 2. So what we have to find? So we have to find all the 2n. We have to find all the 2n length binary sequence. Okay, so we have to find all the binary sequence, all binary sequences of length 2n, that is we have to find, right? So now what does that mean? 2n length binary sequence. Not only that, we have given a property also, so I'm telling you. So firstly we have to find 2n length binary sequences which has a special property. Okay, so we have to find binary sequence of length 2n which has a special property. Okay, which has special property. So what is that property? The property is that if I uh, just bisect the 2n length, I will get n length and n length, right? So if I bisect the 2n length, I will get n and n length. So what does the question is saying? That the number of ones, okay, so number of ones in this n length, suppose this is x, should be equal to number of ones in this length. Okay, so let's take an example. Suppose in case of n equal to 2, so the 2n length is this, right? So the number of ones here should be number of ones here. Okay, so what are the x's possible? Number of ones. What are the values of x possible? It may be 0, no 1. There is maybe 1, 1, right? So I can put maximum how many ones here? Maximum 2, because I have only 2 positions here. If I bisect this one, I have only n positions. So in n positions, I can put at max n ones, right? I cannot put n plus 1 or n plus 2 ones in n position, right? So what I'm trying to tell you is that what are the values of x possible in this case? So if I bisect this 2n length, I have 2 here and 2 here. So I can put 0 number of 1 number of 1 and 2 number of 1. So if I put 0 number of 1, in how many ways I can put this? So I can put 0 number of 1 in one way. So this is this, and the number of 1 is in here should be equal to number of 1 is here. So when x is 0, this should also be 0. So 0, 0. So this is my one answer. Okay. Let's look at other answers. So if I take 1, 1, in how many ways I can put 1, 1? One is 0, 1, another is 1, 0, right? So as here is 1, 1, 1 is 0, 1, 1, 1 is 1, 1, 1 is 0, 0, 0. So this is my one answer. Okay. Let's look at other answers. So if I take 1, 1, in how many ways I can put 1, 1? One is 0, 1, another is 1, 0, right? So one number of 1, so the value of x is 1. Okay, so the value of x is 1, so here also the value of x should be 1. The 1 can be put in two ways, either 0 1 here or 1 0. So the total possibility for this becomes 0 1 1 0, sorry, 0 1 0 1 or 0 1 1 0. Okay, and from here, so I was looking at the first two positions. The first two position I can put 1 1 in two ways. One is this 0 1 and another one is 1 0. In 0 1 case, I can put 1 in two ways. One is 0 1 and one is 0. In 0 1 case, I can put 1 1 in the second two positions in two ways. One is 0 1, one is 1 0. Same way, when I am putting 1 1 in the first two positions, I can put 1 1 in the second two positions in two ways, 0 1 and 1 0. Okay. So I can put rest of the positions like 0 1 or 1 0, right? So this becomes 1 0 0 1 or 1 0 1 0. Okay, so my answer, so let's take the last case when x is 2. So it will be 1 1 only, and here 1 only. So what are the answers? Okay, so look at what are the answers. So the answers are 0 0 0 0, 0 1 0 1, 0 1 1 0, right? So here 0 1 is fixed, and next this 1 0 0 1 1 0 1 0. So 1 0 is fixed, and the last one is 1 1 1 1. So there are 1 2 3 4 5 6. So the answer is 6 because I have to count the number of binary sequences having same number of ones if I bisect the 2 n length. So the sequence is actually of length 4. I bisect them and I get an n length and n length. The number of 1 in this n and this n must be same. Okay. So let's take another example. Okay, let's take another example. Suppose n equal to 3. Right? So I have to find 1 2 3 4 5 6. I have to find 6 length sequences, all the 6 length sequences where if I bisect this in my mind, so the number of ones in this length 3 positions, if it is x, the number of ones in these 3 positions should be also x. So if I put 0 1 0, I can put 1 0 0 here, or 0 1 0 here, or 0 0 1 here, because only in these cases number of ones in number of total ones in all these 3 positions are 1, and here also 1. So those are equal. So let's find the answers for n equal to 3. Okay, so let's find the answer for n equal to 3. So suppose n equal to 3. Okay, so what are the x's possible? So I have 3 positions and I double them, bisect them. The number of x here should be equal to number of x here. So the possibility of x is 0 1 2 and 3, right? So these are the possible values for the x. X is number of ones, number of total ones. Okay, so what is x? X is total number of ones in n positions. So 0 number of ones, one, this is only one case possible, 0 0 0 0 0 0. Okay, next one, when there is a one number of 1, there is 3 cases. 0 1 0 1 0 0 and 0 0 1. So when first three are like this 0 1 0, the other three can be 0 1 0 1 0 0 0 0 1, right? In this in this case also three cases possible: 0 1 0 1 0 0 0 0 1. In this case three cases also three cases possible: 0 1 0 1 0 0 0 0 1. So what are the answers then? So let's find the answers. Okay, so we are not done yet. So x can be 0 1 2 and 3 also, right? So we have take only this case and this case. So for 5, when there is 2, there can be two ones. So it can be 1 1 0 or 1 0 1 or 0 1 1, or is any other cases possible? No. And the last one, so for this one the possibilities here: 1 1 0 1 0 1 0 1 1. For this case 1 1 0 1 0 1 0 1 1. For this case 1 1 0 1 0 1 0 1 1. So our last case is both, all of them are 1, right? So for x equal to 3, there are 3 positions and all of them are 1. So there is one case possible, all of them are 1. Okay, so what are the answers for this part? For this part, one number of 1. And for this part, two number of 1. So for this part, the answer is 0 1 0 0 1 0 0 1 0 1 0 0 0 1 0 0 0 1. Then 1 0 0 0 1 0 1 0 0 1 0 0 1 0 0 0 0 1. For this case 0 0 1 0 1 0 0 1 1 0 0 0 1 0 0 1, right? For this case 1 1 0 1 1 0 1 1 0 1 0 1 1 1 0 0 1 1. Then 1 0 1 1 1 0 1 0 1 1 0 1 1 0 1 0 1 1. Then the last three: 0 1 1 1 1 0 0 1 1 1 0 1 0 1 1. 0 1 1, right? So there are all total 9 cases here: 1 2 3 4 5 6 7 8 9, right? And here also 9 cases. So 9 cases, and the first case is where all the zeros, and the last case is all the ones. Okay. This one, so you have answer as 1 plus 9 cases plus 9 cases plus 1. So these are the rough idea of the problem. Now we have to solve the problem. We can just solve by doing this, all this. We have to find a technique, right? So let's just, this is our case. Okay, so look at this. So now I am going to erase. Okay, so it's a very basic question actually of permutation combination. So there are n position. So n position are there, right? Suppose this is n position, and we have to find 2n position length, right? Where number of x here should be equal to number of x here. So from n positions, listen to my words carefully. From n positions, in how many ways we can? So there are n positions. Value of x can be 0 to n, 0 1 2 dot 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 n, right? So in how many ways I can put x ones? In how many ways? How many ways I can put x ones in n positions, right? So if x equal to 1 and n equal to 3, so in how many ways I can put 1 1 in 3 positions? 1 0 0, 0 1 0, 0 0 0 1, right? So this is actually 3 choose 1. So 3c uh, uh, NCR, you are accustomed with this term, but it can also be written as NCR. Okay, so this is also NCR. So I'm writing this one. Okay, so from n positions, in how many ways we can put x1s? This is the answer, right? This is the answer. And keeping in mind this, keeping in mind this thing, in how many ways we can place one x number of ones in these positions? This is also n choose 1. So we have to do this work m and n. This is m work, this is n work. We have to do this work simultaneously. So the answer is actually m into n, right? What does that mean? That among all the cases of this n choose x, among all the cases, this is one case, this is second case, this is third case, among all the cases, I am actually putting these n choose x cases. So there is n choose x cases for this one, there is n choose x cases for this one, there is n choose x cases for this one, right? So what are these n choose x cases? This is for this one, right? So for this case there are n choose x cases, for this case there are n choose x cases for this position, and this is this position, okay? And for this case there are n choose x cases. So for m cases, each of m cases, for each of m cases, we have actually n cases, right? So for each of n choose x cases, we have n choose x cases. So the total number of cases is n choose x, where x is lying from 0 to 1, right? So this is n, here x number of 1, here also x number of 1. So for n choose x cases, for each case there is n choose x case. So the total cases are this, and the x can be, so what we are doing for n equal to 3, we are adding the values for x equal to 0, plus adding the values when x equal to 1, plus adding the values when x equal to 2, plus adding the value when x equal to 3, right? So that we are doing. Look at the, so let's look at that presentation carefully. So I'm doing, yeah, here, look at here, okay? So when x is 0, this is the case. So I am adding this one with which cases? When x is 1, this is the case when x is 1, this is the case when x is 1, right? This is the case where x is 2, this is the case where x is 3, this is the case where x equal to 0. So I am adding the cases for x equal to 0 with the cases with x equal to 1, with the cases with x equal to 2, with the cases where x equal to 3, right? So what I want to tell you is that for n choose x cases, we have n choose x case. So in total we have n choose x into n choose x cases, and if I put x equal to 0, I will get this as this, which includes all the cases where the position n and position n, here is the 0 1 and here is 0 number of 1, right? So here is 0 number of 1 and here is 0 number of 1. So I have to sum this with all the cases where there is one number of 1 and there is one number of 1. So it is n choose 1 into n choose 1. I have to sum all the cases where here is 2 number of 1, here is 2 number of 1, n choose 2 into n choose 2. So plus I have to add all the cases like this where I have x number of 1 among all the n positions and x number of 1 among all these positions. So what does that mean? I want you to understand that. This means all the cases, all the answers, okay, all the answers where this in this 2n length, this first n part contains x number of ones and the second part contains x number of ones, right? So after all the cases where there is 0 number of 1 or 1 number of 1 or x number of 1 or n number of 1, right? I hope you understand. So actually the answer is n choose 0 plus n choose 1 plus n choose 2 plus dot plus n choose n into n choose n. So what does that mean? N choose 0 square this square plus n choose n square. So what does that means? I equal to 0 to n choose I square, right? And the value of this is actually 2n choose n. So you can check YouTube or any Google. So the value of this, this one, n choose 0 square plus n choose 1 square, or you can say this is actually what is actually n choose 0 square plus n choose 1 square plus n choose 2 square plus dot plus n choose n square. Actually this value is equal to 2n choose n. So I am not doing this because you can get in Google or YouTube or anywhere in your books, textbooks. So the value is actually equal to 2n choose n. Okay, I hope you understand. So I hope you understand how we approach to this level. Okay, so our answer is actually nothing but 2n choose n. So this is our answer actually. Okay, so let's code then. You have to just calculate n 2n choose n. So we are not doing this in Java. Java will take many long solution. We are doing this in Python. So what I am going to do, I am going to import a class first. Okay, so I am going to just import a class called math, and I am taking a value mod which is equal to 10 to the power, right? This is the symbol of power in Python, 9 plus 7. Okay, now what I am going to do, I am going to calculate factorial of what? 2n, right? 2n, and I am going to calculate factorial for n, and I am going to do, yeah, so what I was telling you is that so 2n choose n is what? 2n factorial by n factorial into 2n minus n factorial. So this is equal to 2n factorial by n factorial into this is n factorial. So this is 2n factorial by n factorial square. Okay, so we will find this factorial and this factorial, and we will square this one and divide by this. So I am dividing a modulus this mod value. I hope this works. Let's compile it. So I have to do here floor division, not a normal division. Then I will return this. So I hope you understand. I'm just doing 2n factorial, then n factorial, and dividing the 2n factorial by n factorial square and giving the mod value, as this can be a very large number. Then I'm compiling it. So this is our answer. Let's submit it. Yeah, so we are done. So thanks for watching. So see you in the next video.